been tragic. All right. So we have a 55-degree angle. So here's my opposite, hypotenuse, and then also adjacent. Which trig function did you guys use for this one? I would say tangent. Using a little bit of forethought here. If I'm doing, it's either going to be cosine or tangent, because that involves a, and I know something about a. I can't use sine in this case. So cosine or tangent. Now, I think tangent makes more sense because then we don't have a situation like this. It just takes one more step. I prefer it when the known side is on the bottom versus the variable, the variable being on the bottom. So we're going to do tangent of 55 equals the opposite over the adjacent, so x over 8. So again, this is kind of the easier of the two types, I think, because now I can just multiply each side by 8 to get my x value. Okay, so once I know x, how do I find our y? There's a couple of different ways to get there. How would you guys want to find y? Pythagorean theorem works really well. That becomes kind of like our warm-up question, where I know two sides of a right triangle, so I can find the third side by Pythagorean theorem. You could also use trig if you wanted to. You could do cosine, and that would give you the hypotenuse. You could actually even do sine, and that would give you the hypotenuse, so that would work as well. I think Pythagorean theorem works nicely. The only thing is when we have like a decimal like this, we just want to be careful on our rounding. So I actually take this really long decimal and I leave it in there, and then I just square it so I don't have to retype it. So I'm basically doing this 11.4 squared, like with more decimal places, plus 8 squared, and that's going to give me my y squared. So I found out I ended up having to take the square root of those two together, and I end up with like 13.9. Now yours might be a little bit different depending on how much you rounded with your 11.4. So you might have had a slightly different, I guess you got the same thing, I just checked it. If you used 11.4, you should get the same outcome. All right, guys, why don't you guys try number 6 if you haven't already? Take a minute there. I'm going to start going through this one. Hopefully this one wasn't like a stumper or anything. It's pretty straightforward. We can either use sine or cosine. It's up to you guys which one you use. So if I do sine of 21, that's my angle, equals the opposite over the hypotenuse. Now that you've gotten the hang of this, actually trig might even be easier than Pythagorean theorem now, I think, sometimes. Because it's just a multiplication. I'm not having to move things around too much. Because then I can also do cosine of 21 equals y over 22. I'm basically doing the same thing in each case where I'm multiplying each of them by 22 to find my side lengths. And there's no decimals really until the very end, so it works out very nicely. I get 7.9 for my x. And my y is 20.5. And again, taking a minute to make sure that it makes some sort of sense with our drawing, that you're not like surprised that you got some crazy number and it doesn't make sense for the drawing. All right, in number 7, they just want us to, actually I might take this one a little bit farther. So they say find the missing side, then they'll find the value of sine of a and cosine of a, and then we're actually going to talk about how we find the value of a. If you've forgotten about that, we'll remind you of that. So finding the missing side, we have to use what in this case? Pythagorean theorem. We have no other options. We have to use Pythagorean theorem. Well, I guess we have other options. We could go in a very bizarre manner to figure out the hypotenuse other ways, but it's probably easiest at this point just to do Pythagorean theorem. I'm going to call that side C. It's like our hypotenuse, so and I find out C is about 16.1. Now what they want the value of sine of a and cosine of a. So basically they're asking you just to set up a ratio here. So sine of a is opposite over this hypotenuse. And cosine is the adjacent over the hypotenuse. Do you guys remember how to find that angle? What if I actually want to find the value of angle A? Yeah, this is where we use the inverse cosine or sine, and that's our tangent. That's the number, like the little buttons, like probably right above your sine, cosine, and tangent on your calculator. So if we're trying to find the value of angle A, I can do the inverse sine, cosine, or tangent. And to be honest, I would probably actually use the tangent. The reason why I'd use tangent is because it's a nice whole number. So if I'm trying to find angle A, I'm going to do the inverse tangent of this same fraction. So the opposite over adjacent is my tangent. We're going to do the inverse tangent. Again, you might have to hit the second button on your calculator. It's like right above your little trig functions there. And I get like 60.3 degrees. Again, if you're getting something weird, probably something's going on strange in your calculator, so we can try and figure that out, so let me know. And you should get something very similar if you did sine of A or inverse sine of A, even if though it's a decimal. Yeah, I got like 60.4 if I did this decimal because we had rounded there. Whereas this is a little more exact because those are nice whole numbers. Doing okay here? All right, so these last two don't give us a drawing. So it kind of leaves things up a little bit for grabs here, but it's still not bad. So what we need to do in this case is they want us to solve the triangle. Solving the triangle means I find all the sides and angles. So when you see the word solve, it means find all sides and angles. Now they tell us these are right triangles because they give us the fact that angle C is 90 degrees in each of these cases. So that is helpful that we know it's a right triangle. So I'm going to draw our little right triangles here. Now don't feel like your drawing has to be like amazing, that you're like, oh, that looks totally like a 32-degree angle. It's fine if it doesn't. So I'm going to write, I'm just going to call this smaller one 32 degrees so I'm not confused as I'm checking this. Now when we label this, hopefully you realize the other side, the other angle would be angle B because of the fact of kind of cross elimination. And we haven't talked about this yet. Typically, the little b is across from the angle B. So this is across from angle B. So little a would be across from big A. Little c would be across from big C. That's usually the way we label these in trig. So we're going to find all the missing sides and angles. So we're missing an angle and we're missing two sides, because we know angle B is 24. What looks easiest to find first? Angle B, I agree. So we are looking for angle B, we're looking for little a, and we're looking for C. So big B is easy to find because we know the angles of a triangle add up to what? 180. So we have 90, we have 32, so our leftover then is 58 degrees. So that part of it's not technically trig, that's more geometry there at that point. So 58 degrees is because they add up to 180 degrees together. Now we want to find side A and side C. But I already know this angle 32 and I have the side of 24. So we're going to set up a trig ratio. Here's my opposite, and here's my adjacent. And then this is hypotenuse. I'd probably start with tangent to figure out little a. Now it's kind of confusing. I'm calling opposite little a, so that might be confusing. Sorry, opposite over adjacent. I got like 14.996, so if I'm rounding, that's really actually going to be 15 for little a. And then I can find C either by Pythagorean theorem or trig, whatever you're more comfortable with. I did Pythagorean theorem. I got like 28.3. You could have done like sine or cosine, probably cosine I would probably say. Why don't you guys try this last one before we end today? We'll give you guys a little bit of time if you haven't already. Label everything you know. You're probably going to have to find an angle first. I guess you find the side first, but you're going to have to find angles anyway. I would draw what we got going on here. So we need to find angle B, angle A, and then also little b. Now if your drawing doesn't look like mine, that's fine. The biggest thing is C has to be a right angle and little c has to be across from that, so that has to be your hypotenuse. Where you have everything else doesn't really matter. The way you have it drawn doesn't really matter as long as it's the right triangle. Yeah. Yeah, sure. Yeah, thank you. That's the fourth. I don't know if it's first name or something.
Well, if you can get that on there, that'd be nice. Did you get the 32? Right now, you're right there. You're done. You have others?
So, Diego, what did you do first? You look so excited to show him. What did you find first?
I forgot.
Well, tell us something.
I did the Pythagorean theorem to find b, I'm guessing.
Okay, so did Pythagorean theorem to find b. You don't have to do Pythagorean theorem. You could end up using trig, but it would work if you use b, or if you're trying to find b, c has to be your longest side. So remember, it's kind of like our warm-up question where we actually end up subtracting these two. So I move that 20 squared over, and then I take the square root and I find out that b actually is 21 in this case. So that actually works out very nicely because it's a Pythagorean triple, which means that we don't have any decimals for our side lengths. Now our angles will be decimals though. All right. So we have our side of b is 21. What's it? Yeah. Otherwise there's one over there and I will be bumping into that. Alright. Matthew, which angle did you find first? You found B. So if we go for angle B here, I'm assuming, I guess it doesn't really matter because they're all nice whole numbers, but if you use A and C, this is technically my adjacent over my hypotenuse. So this I would do cosine of B. Whoops, my board doesn't move on me. Cosine of angle B is going to equal 20 over 29. We haven't done many like this yet, but when I go to solve for that angle B, I have to do the inverse cosine of 20 over 29. So you don't change anything about the problem except now we change it to that inverse cosine. It's kind of how we undo that cosine. And I got like 46.4 for my angle B. Now remember, angles are degrees, so please use degrees for the angles. Now, once I know B, I technically don't have to use trig again if I don't want to. If you want to, you're welcome to, but I would prefer just to use simple subtraction or arithmetic, that I know this is 90, I know this is 46.4, so I know all together they should add up to 180. So what do I get, 43.6? Yeah. So angle A would be 43.6. All right, so we're ending extra early today. I'm sorry. I know I'm sure you're not heartbroken, but this will not always be the case. I'm still trying to work out timing since again, this is my first time teaching trig here. I have to kind of figure out what the best timing is. So your homework is going to be typically on worksheets And again, if you, for some reason, forget this here at school, feel free to go online. There should be like a scanned version of this worksheet as well. And you can always do it on loose leaf. So just because you don't have the worksheets, no excuse not having your homework done. And hopefully you just use your time now and then you don't have any homework.
Could have given me a paper cup.
It's been tragic.
Take it up, dog.
That's a little